Hi friends, we are going to discuss about one of the important topic in discrete mathematics. So it is functions, right? So in the last chapter, we discussed about the introduction of relation, what are the different types of ordered pairs that we can generate using those relations. So all those things we discussed. So today we will start with this topic. So what is called as a function? A function is defined as a relation between a set of inputs having one output each. That is, we are going to create a function in such a way that for each and every input that we feed into a system or in any type of languages, we are going to give an output. That is, the system is going to generate an output. So how the discrete max is helpful for us in order to generate these types of output, right? So in order to generate the output, we are using the very important concept is called as function. So normally in programming languages, we are going to feed values, we are going to give some problems so that we are going to get the exact output what we prefer. So for this, behind the screen, as I said in the previous video, discrete max is really very helpful for us friends, right? So here we are going to discuss this concept. So in order to generate a function or in order to define a function in discrete max, we are going to use two types of terms. So it is called as domain and codomain. Okay, so domain and codomain are the two things which we are going to use it for creating a mapping between for what input, what output has to be generated. Next one, a function is generated denoted by f of x where x is the input. So f of x is nothing but the output what we get. So x is nothing but the input what we are going to feed. Friends, can you follow? So now we are going to see how to generate this f of x by using this x, right? So now we will discuss about function representation. A function is represented as f colon x gives y. So this is a representation of a function. So here you see x stands for input and y stands for output, right? So this is actually indirectly means as f of x is equal to y, where f is a function that holds the two values x comma y, where x is the input and y is the input. Okay, capital X and capital Y represents the total number of values that are being present in a set. Okay, in a set. So in that, there are some values stored in capital X and there are some values stored in capital Y. How those values are mapped to values of Y. So that we are going to create, that is input to output, right? So next you see, for any function, the notation f of x is read as, see how it is read, f of x. I think you all might know it. So the value of y when x is replaced by the number or the expression inside the parenthesis. Okay, so value of y is going to be where we are going to replace with that of x. Okay, so x is equal to 1 now. Y we are going to find by replacing that x value. So that we are going to see with some example. So see here, output is the another name for image. That is, y is output from x, isn't it? So I am telling output as an image which is called as y. Similarly, x is called as the pre-image of y. Okay, so these are all some general terms. So now we will see the diagrammatic representation of a function. So this diagram will helpful to know how x is related to y. Okay, so the range, what is the meaning of range, that we are going to see. So range of a function refers to all the possible values y could be. So that is, I am going to generate certain output from x, right? So those outputs or possible types of outputs that we are going to get is called as the range. So the formula to find the range of a function is this, that is y equal to f of x. Okay, so y is output. How we have got the output of y? So it is nothing but from the set of inputs or from the function of x. Not all the x values is going to produce me the output. So there are certain values present in x. It is called as f of x, which is going to give the output of y. So now this is general diagrammatic representation. See here, x is a capital X is a set, y is another one set. So x is holding certain values x, I, k, and y is holding certain values y, n, o. Okay, so if I want to get the output o, I need the help of x. Can you follow? Again, if I want to get the output of n, I need the help of what? L. Again, if I want to get the help of y, I need the input of k, sorry. So these arrows represent the outputs that are dependent on these x values. Okay, so this is the way for representing the range of a function, how the input and output are correlated within each other. So here you see the terms that we discussed in the previous screen are being represented in the form of a diagram. See, domain, codomain, right? So this is the function that is going to create the output for me. Okay, so what is called as a domain? Set of values that are present in my input side. So range is a set of output that I got from this domain. See, 1, 2, 3, 4 are domains. Okay, so codomain is nothing but 1, 2, 3 and 4, right? How many number of outputs I am getting? 2 and 3. Okay, so 2 and 3 are the outputs that I am getting from the domain. So 1 comma 2 combination is going to produce this output 2. Okay, again 3, 4 are going to produce this output as 3. Can you follow? So here the range are 2 and 3 friends, right? So 1, 4 will not come because 1, 4 is not dependent on the domain side. So range is nothing but only 2, 1, 3. Clear? So next we will see classification of functions, that is what are the different types of output dependencies are possible. Okay, so one type of a function is called as one-to-one. Then we will be discussing about many-to-one, and then we will be discussing about one-to-many and so on. So we will discuss each and everything individually. So now we will see one-to-one function, that is how the input is going to generate the output based on certain types. So first type is one-to-one. Okay, so as usual, this is the expression A gives B is called as a one-to-one. If listen, if for each element of A there is a distinct element of B, it is known as one-to-one function. Okay, what is called distinct? So distinct is nothing but unique output. The output should not be repeated. Okay, so that is called as a distinct. Can you follow? Distinct is nothing but unique. So another name for one-to-one function is called as your injective. Okay, so this is the diagram that represents one-to-one relationship. Okay, so A is going to produce the output for B. Okay, see now how many number of elements are present? A1, A2, A3 and A4. And in B, how many number of elements are present? B1, B2, B3 and B4. Okay, so A1 is going to produce output of B1. See the arrow mark? Okay, and A2 is going to produce output for B3. And A3, see the direction of arrow? So A3 is going to produce output of B2. And A4 is going to produce output of B 4. So each and every input is giving a unique output, not the repeated one. So this type of representation or a function is called as your one-to-one function. So the another name for one-to-one function is called as your injective. Okay, so now we will go for many-to-one function. So what is called as a many-to-one function? It is a function, see here, which maps two or more elements of A to the same element of B. So from the word itself you will be able to understand what is called many-to-one. Okay, so two more than, that is more than one input is going to produce some exact output or same output. So another name for this A is called as pre-image and B is called as image. Okay, that you must have to remember. See, two or more elements of A have the same image in B. Can you follow? So see, this is the example for many-to-one. Same elements A1, A2, A3 and B is nothing but B1, B2 and B3. So in order to get my output as B1, I need the combination of A1 and A2. Can you follow? So A3 to B3 represents 1 to 1. But A1, A2 giving B1 represents many to 1. That is, in a function you can have any types. So this diagram represents both many to 1 as well as what? 1 to 1. So here can you tell me what is the range? So here the range is B1 and B3. Okay, domain is A1, A2, A3. Codomain is B1, B2, B3. But the range is only B1 and B3. Can you follow? So now we are going to discuss about onTo function. So the main important function of onTo function is for every element of the set B, okay, there is a pre-image or more than one pre-image in set A. It means all the elements in the B side should have at least one or more than one dependency, okay, it should be connected. So that type of relation, that type of function is called as your onTo function. So another name of onTo function is surjective function, friends, right? That is, in the set to be in the output, all the elements B1 should have an input, B2 should have an input, B3, B4, B5 all should have an input. None of the output elements should be not blank. Okay, so this is called as an onTo function. Okay, can you follow? Right. So this is one example. So see in this example, so there are inputs A1, A2, A3, A4. In B we have how many number of elements? B1, B2, B3, B4 and B5. Can you follow? So each of the elements, say B1 is having an input, which is the input A2. Again B2 is also being connected, which is that A3. Again B4 you see it is connected to A2. Similarly, in the B5 is also having an connection with A4. So here if you see, all the elements are having an pre-image. All the elements are having the pre-image. So none of the elements in B are left out or left blank. So this is called as an onTo function. So in this type of functions, if you see, the number of codomains and the number of ranges will be same because all the elements are being connected with the pre-images, right? So here in onTo functions, range is equal to codomain. So this is one of the important point you should have to remember. Okay. So next we will discuss about one-to-one and onTo function. So what is called one-to-one and onTo function? If the function is having both one-to-one satisfied as well as onTo function satisfied. Okay, so both these conditions, if it is satisfied, it is called as your bijective function. We discussed about injective, surjective, and now we are going to discuss about bijective. So now tell me what is called one-to-one. So for each input, there should be distinct output. This condition should also be satisfied. Then what is called onTo function? All the output should have an input. None of the output should be left out empty. Okay, so in a function, these two functions has to be satisfied. If it is so, it is called as bijective function, friends, right? Very easy, no? So next we will go for composition of a function. What is called composition? See, chaining. Chaining is nothing but normally in algebraic functions, that is in mathematics, we will be substituting some values of x with values of some other functions that is being given for that x. Can you follow? For example, if y is equal to 2x plus 3, where x equal to a. Like this, if they have given now, how we will be substituting? So y is equal to 2x plus 3. So what is the value of x? X is given as a. Please understand. So now the output of y value will be 2a plus 3. Am I right? Because I have substituted the value of x as a, which is being given in the problem. Same thing is this one, friends, right? So chaining of two or more functions together. So the output of the first function serves as the input of the second function, right? So it is called as your composition function. It is nothing but algebraic substitution. Okay, so here is a general representation of your formula. F is equal to A gives B and G equal to B gives C. So indirectly I can tell as what? A is equal to C, meaning is instead of B I will be substituting some C value. Okay, can you follow? So can be composed to form a function which maps x in A to G of f of x in C. Okay, see g of f of x. See, please remember this one, g of f of x. So meaning is, see, I will explain you with the diagram. So general representation of g of f is this one. So g of f is read as g of f of x. So this one. Can you follow? This is a simple denotion of this statement. So now, before discussing this diagram, we'll go for some example. Then you'll be able to understand very easily. So this is one example. Try to understand, friends. We have three sets. Okay, A is equal to 1 comma 2 and B is equal to 3 comma 4 and C equal to 5 comma 6. We have three sets. From these sets, we have formed three relations. So relation name is R and the relation name is S. Okay. So R is holding certain set values. So they are, that is ordered pair values 1 comma 3, 2 comma 4. Okay. So now S is going to hold certain values. It is 3 comma 5 and 4 comma 6. Now they have given as S composition R. So how we are going to read this? So it is S of R. That is, in the place of R, I will be substituting R values. Okay, then after substituting this R values, I will be getting some result. Okay, so in that result, I will be substituting S value. So see now, this is the example. So now take this as, first you should have to derive the inner function S of R of X. Like this you should have to keep in mind. So what is R value, R of X value? So these are the two values 1 comma 3 and 2 comma 4. So now you take the first element. So what is the first element? So it is 1 comma 3. Take the second value 1 comma 3. So from 1 comma 3, then from 3 to which value we are going to travel? To S. So 3 is going to produce 5. Am I right? So 1 comma 3. So from 3 I can move to 5. So what will be the final answer? So final answer will be 1 comma 5. So this is the meaning of S of R, friends, right? So from 1 comma 3, from 3 I am moving to yes, okay, that is having 3 as your first element. Okay, so that is having 3 as your first element. So from 1 through 3, I am getting what? 5. Understand? So from 1 through this 3, I am getting the value as 5. Because 3 is common here, right? So I can replace this 3 as 5. Okay, so now you take the second element. What is the second element? 2 comma 4. Okay, so 2. Okay, what is the next element? 4. So from 4 also through 4, is it possible for me to move anywhere? Yes, I can move. See here the next element. So through 4, I can get 6. Yes or no? So from through 4, I can get 6. So what will be the final output? 2 and 6. Okay, so here this 4 is acting as a substitution factor in order to get this value as S of R. Can you follow? So linked word. So 1 is linked to 5 through 3. Again 2 is linked to 6 through 4. Can you follow? Right. So that is the meaning of your composition function. So here this is given as your diagrammatic representation. A, B and C, X, f of x is equal to y. This gives one answer. So through this answer, I am moving to final answer g of f of x equal to z. Can you follow? So through this, I am moving to g of f of x. So this is called as g of f. Okay, first I should derive this one and then I should derive this one. From the input, I am getting some output that is called as f of x, and through this f of x, I am getting the another output that is g of f of x. So this is a general definition. I think you will be able to understand this. Interpreting the definition above. So a comma b belongs to R and b comma c belongs to S. It means S of R. Now what is the meaning? Through B, I am getting C. Through B, I am getting C. Now A comma C belongs to S of R, right? Okay. So now we will discuss about inverse relation. This is also very easy, okay? So from the example itself, you will be able to understand what is called as an inverse relation. I am going to reverse input to output as output to input. That is, output is going to act as an input. Okay, so reversal. Okay, I'm going just to reverse input to output. It is called as an inverse relation. So this is the general representation. Okay, so B to A, that is output is changed as an input. So if A is an input, B is the output. So what is the inverse? B will become the input and A is going to be your output. So see this example, consider relation that maps each person to their ages. So John, 30, Alice, 25 and Bob is 35. So John's age is 30, Alice's age is 25, Bob's age is 35. Okay, so what will be the inverse relation? So would map each age to the corresponding person, r power minus 1. Okay, this is r power minus 1. So what will be the answer? 30 age is mapped to John, 25 age is mapped to Alice and 35 age is mapped to Bob. Just reversing. So friends, that's all in the session. So here we discussed about different types of functions, what are all the way we can implement these functions. Okay, I think this session will be really very useful for you. I request you to share this video to many of your friends so that they'll be having a good idea about these types of functions. Okay. If you are interested, I can also give certain problems related to the relations present in the previous videos as well as in the current video. Okay, we can discuss it even in the comment section. So post your valuable comments, friends. Thank you and bye.